talk briefly about solids. So a couple of things you know definitely about solids. They have a definite shape and a definite volume. And you can't really easily compress them. They maintain, they're rigid. So a big thing about solids is that they are very orderly. They have fixed attractions, and the particles are in a location that they're not moving. So it would be like if you never got to change seats, you were always with the people that sat next to you on the left and the right. Solids are typically the most densely packed. They're the most dense state of matter, and it's because their particles are the most closely held together. Water is is a very important exception to this, with our liquid form of water being more dense than our solid form, which is ice. But in most cases, that's not the thing. When you have a solid, typically you have things made of crystals. Not everything, but most things have crystallins, and they have unit cells. Again, they're going to be held with the strongest attractions, the strongest intermolecular forces. When you have solids, you can have allotropes, and allotropes are when you have things that can have more than one form. So they are solid forms of the same substance, but they just look different. And the classic example is carbon. There's more than just these three, but these are just three examples. So the most common form that you probably like is a diamond, and that's a tetrahedrally bonded thing, which I'll show you on the next slide, of carbon. It's all carbon atoms. You can have graphite, which is what you write with when you use pencils, and this is actually like sheets, so you actually write with sheets of graphite, which is pretty cool. And then you can also have fullerenes, you can have buckyballs, you can have different stuff. But they're all just carbon, and they just look different. So you can see here, this is diamond structural formula. This is graphite, so this is your pencil that you write with. We have fullerenes, and then we even have the nanotubes, which are just pretty cool. But again, all the little dots here, they're all carbons. It's just different forms of carbon, which is what an allotrope is. On the other side of things, if most things are crystals, but you can have what's called amorphous solids, which basically means that they don't have that order, they don't have that structure to them. One cool thing about amorphous solids is that because they have this like kind of weird attractions and stuff, they don't break nicely, and what we have is we have shattering, and we have they don't melt at one temperature, they melt over a range of temperatures, which is why like glass, people can do the glass blowing and stuff, because it doesn't just become a liquid. It becomes kind of like semi-liquid, and that's because it's amorphous. So the two most classic examples of this are the glass and ceramics of that one. And then just with solids, we said it before, if you're going solid to liquid, you're melting, and that's because you're breaking some of the intermolecular forces, and that would require energy. And going from a solid to a gas, you are completely breaking all attractive forces, so this takes a lot of energy, and you're going basically from the most ordered to the least ordered. And this is just a picture of good old dry ice, and you can kind of see the chunk in the middle here, and then you can see the vapor coming off. So this is video 6.